Hello everybody, I will present the paper A Multi-Year Sensors-Based Environmental Monitoring Approach to Access the Quality of Bike Paths in Urban Areas. This paper was written by Franklin Oliveira, by me, Daniel Costa, and by França Dias. And we are all from Universidade Estadual de Feira de Santana, Brazil. This is the overview of this presentation. I will describe the problem scope. We will present the proposed approach with fundamental concepts and the monitoring system, and I will talk about the spec results and the conclusions of this work. Nowadays, we have some serious urban mobility issues with heavy traffic conditions and inefficient transportation system. Moreover, we have different levels of pollution resulted from this poor mobility in large cities. We have air pollution and noise pollution. So the initial conclusion we have is that we need to reduce the number of vehicles in the cities. And this complex scenario has created a demand for alternative mobility, transportation, and also healthier habits. And this have created a good demand for bikes and bicycles as a transportation mean. However, people are vulnerable to pollution and bad weather conditions. And all these conditions may have terrible impacts on the health of cyclists. So the questions that we have are, what's the impact of external conditions to the health of cyclists? And two, how to choose safer and healthier places to cycle. In this scenario, we have proposed the BikeSensor approach, which is a multi-sensory approach to access the quality of bike paths in large cities. This is actually a supportive tool to promote a better quality of life. What are the spectral services? First, to support historical quality assessment of bike paths, exploiting indirect health parameters, retrieval from sensors, so we process sensor data to have a better historical perception of the quality of bike paths and to indicate whether bike paths are adequate for cycling. Because we want to support the creation of new bike paths. Have historical information about the quality of bike paths can support governments to decide where to create new bike paths and how to improve the quality of current deployed paths. The BikeSensor system is expected to have a low-cost requirement using low-cost electronic devices. It should be easy to use and to configure, to adapt. It's sensor-based. It's a collaborative tool, and it allows offline operation. It was an initial concern because you want that the monitoring using bikes could be employed even in the absence of infrastructure. So we don't require a WiMAX connection, Wi-Fi connection, LoRaWAN connection. The operation is offline, and only when the bike has active connection, we retrieve the information that will be sensed by each bike. So it will be easy to reproduce. It will have a monitoring flexibility, so depending on the city characteristics, we may deploy different sensors units to retrieve different types of data, temperature, humidity, pressure, ultraviolet radiation, air pollution, noise pollution, and will be back to operated. So we expect that each bike will have a sensor unit composed of different sensor devices and will be powered by batteries. This is the logical structure of the proposed system. We have two different units. The MMS, that is the mobile monitoring station. There will be one MMS attached to each bike. We will have a DCU, a data central unit that will process information retrieved from each bike, and a BikeSensor client. Actually, we may have different BikeSensor clients, but it's just an app or web-based application that will retrieve information from this DCU and present those information in graphs, on a map, as historical histogram to better to provide better means for visualization. The mobile monitoring system is the key element of the proposed approach. There will be expect to use to create it using Raspberry Pi Zero board, and it will have our operation cycle divided in some logical states. First it is in the idle state. You have a setup state that allows that we configure the station for a home Wi-Fi connection, because we expect that a cyclist will ride from one point to another, from his home, her home to the work or to a park, and the home will be available Wi-Fi connection. So we need to configure it and the implemented sensors during the setup phase. We also have a monitoring phase when the bike will be riding, and we also have an upload phase when the MMS will transmit information to the DCU. We have some configuration buttons to change from idle station to setup, and change from monitoring station to idle. The upload stage will be something automatic, because when the bike will have a active Wi-Fi connection and also it has monitoring samples, the transition from the idle to the upload state will be automatic. The idea is that a single MMS unit will be attached to each bike. Okay? The DCU and BSC modules will be software modules that will be deployed on conventional desktop computers on a server, or even in the cloud. The monitoring samples are stored in the MMS, and after they are transmitted to the DCU, reformatted and transmitted to the BCS for visualization purpose. This is the MMS Prototype. We are using the Raspberry Pi Zero. It has one board Wi-Fi connection, it has a decent processing power and memory capability, and more important, it's cheap. We designed a specific hat extension to be used on the Raspberry Pi, connected to the GPIO, and different sensors. We have a digital to analog converter and some sensors, and all this unit is powered by a power bank, rechargeable power bank, and we are also designing a case, printing a 3D printer to allow easier connection to the bike. These are some information we have in your DCU file system. We are using CSV files. They are more efficient and easier, more flexible to configure and to transmit. Okay, this is only we are in the initial stage of development. We expect to conclude the development of MMS and have some more practical experiments to have more accurate data for validation of this idea. So we designed a new multi-tier distributed approach for active monitoring from bikes. Okay. The systems tend to be easy to configure and operate. Okay. We are using low-cost components. Some sensors we are using from indoor monitoring. We are testing them if they are adequate for a bike, since the bike is moving. We have moving source of pollution. For example, cars are creating noise pollution, but they're moving, and the bike are moving. We have the Doppler effect. So we are considering all this information. The logical structure of the system were described in your initial results were presented. Okay, we are still in the implementation phase, but we are very excited about it. And as future works, the implementation of the 3 logical models will be concluded. Okay, we are very close to that, and we will perform further evaluations. Okay, thank you very much.